Hello and welcome to CodeRash with Gaurav. Let's learn developing and designing software in a practical way and for free. CodeRash brings you insights about interview preparation, coding exercises and lot more. So stay tuned and subscribe for more.
Hi there, welcome to another video. In today's video, we are going to look at higher order functions in JavaScript. We'll look at what is their use, how do higher order functions ease our life. We will also look at how higher order functions help us in implementing a design principle called as inversion of control. So stay tuned and stay subscribed. Let's begin. Before jumping into the higher order functions, let us look at a usual way of writing functions or utility methods that we usually do. We are looking at a people list here where individual entry is a person having its name and age, and we are writing some utility methods to get their respective types based on their age criteria. Let's say we are trying to get adults who are of the age equal to or greater than 18 and less than 60, and minors who are less than 18, and senior citizens who are equal to or greater than the age of 60. So we are writing three utility methods for this, and we are just invoking them, passing our input list as an argument to these utilities, and we are just logging them. So let me run this code and see what do I get in the output. Senior citizens who are falling in our criteria are Michael and Stanley, having age equals to or more than 60. Let us look at minors. Minors is only Aaron, having the age of 16, and adults. Four individual entries match our criteria, who are Jim, Pam, Dwight, and Andy. Now this simplistic way or the usual way of writing utility method works, but it has got some problems. Let us look at what are those problems. If you look at these utility methods, they are of very similar in nature. In all these utility methods, we are trying to filter down the input list. The only thing that changes over there is this input criteria, the filtering criteria, which is the core business logic. Now, this also explains you that our implementation of utilities is very much tied to the business logic. Imagine the case where you are writing a library from which you are exposing these three methods or these three utility methods, and there is an ever-changing requirements. The business logic changes. Now, let's say tomorrow the minors, the criteria for minors is less than 16. Now what do you do in this case? Either you modify the same method or you expose another method, get minus v2 out of this library. Now this also had got some problems. With the change of requirements and the change of business logic, you keep on changing the core of your library, and you are getting more and more units to test. The testing of these individual units also is increasing based on their tight coupleness to the business logic, and you are not able to handle the ever-changing requirements very easily. There can be more than one consumer of your library. So if you change the existing function over here, whoever is consuming your library, their logic might break. So how do you handle all this? And for sure, you don't want to keep on repeating your code. So let us look at how can we implement this with a higher order function and solve all these problems. Let us first see what exactly is a higher order function. A higher order function is a function that takes another function as an argument or returns a new function from it. As simple as that. So we'll try to see how can we solve this problem of repeated code and coupling with the business logic with a higher order function. So let us write a common function or a common utility that serves the purpose for all these utilities. So let us write a generic function and let us give it a common name, get filtered list, which accepts two parameters, input list, let's call it input array, and a logic. And this guy is going to return input array dot filter based on whatever is the logic the consumer application is providing us. Now, when we are calling this get filtered list, we will have to pass two parameters to it, the logic as well as the input list. We are already passing people list as an input array here. Let us also pass the logic. For senior citizens, let us pass the logic as the method that we are passing to filter in the individual utility. Now, because this filtered list accepts a function as an argument, this becomes a higher order function. Let us do the same thing with the minors and the same thing with adults. So with this, I can get rid of these individual utilities that I was writing before. So now the code looks cleaner. I have got only one utility which I'm going to expose from my library, which is get filtered list. I accept an input array and a logic. Now, since this logic is externally injected into us as a library, we are independent of the business logic. So the tight coupling with the business logic is gone in this case. And we are also out of the scope of ever changing requirements. Now, let's say consumer 1 says that the minors criteria is less than 18. So we don't bother about it, like, because you are only injecting the logic here, you take care of it. And same is the case with, let's say, consumer Y. They say tomorrow that for us the minors criteria is less than 16. So they also use the same library in the same API input parameters way, just that for them the logic would be different. And for us as a library, there is less repeated code, there is less dependence on the business logic, and there are now less units to test. We can test this get filtered list independently without any business logic. We can mock some business logic out of it, and we can test this guy as an individual method. There's a good read I recommend you at this point of time. Read about solid principles, open close principles, and the things that can be tested individually. It's a good read about solid principles. So let us run this code at this point of time and let us see if we are getting the same result back. Senior citizens, as previously we were getting, Michael and Stanley, who are matching our criteria. Minors should be Erin, and adults should be Jim, Pam, Dwight, and Andy. So you saw that we are now done with repeated code. We are not repeating the same filter logic again and again. We have less dependence on the business logic, and because this get filtered list accepts the input as a function, which was the filter criteria, this guy is called as higher order function. So if you look at the higher order functions by the definition, all the input array methods like the array filtering, map, reduce, all these methods on the array are also higher order functions that way, because they also accept a function as an argument. Let us look at what inversion of control is. Inversion of control is a software architecture or a design pattern where a library or the reusable component lets the consumer take control of what the functionality could be, and it provides an abstraction on top of it. And that is what we did by writing a higher order function. We allowed the consumer libraries to inject some kind of a code or logic into our library and get the functionality which they want. That way our library remains abstract, reusable, and it becomes easy to write and test. So this way our control that we are writing becomes inverted, where somebody else can inject logic into us. So this particular pattern or the way of writing controls is called as inversion of control. This is an important question to remember if you are preparing for design interviews related to JavaScript. This is an architecture style which is called as inversion of control. And in your daily life, you will see a lot of implementation of inversion of controls. The dependency injection in React or Angular frameworks works on the principle of inversion of control. The reducer patterns, how they work with Redux, they are also based on inversion of control. Let's summarize what we saw in this video so far. We saw a usual way of writing utilities from a library. We saw what can be the problems in the way we are writing code. And then we saw in detail what are those problems and how are we trying to solve those problems with higher order functions. We also looked at what is an higher order function. We understood the definition of it, and which is as simple as a function which takes a function as an argument or returns a new function. We also saw how implementation of higher order functions can help us achieve a design pattern which is called as inversion of control. We understood what is inversion of control and why it is useful. If you like what you saw, leave a like and tell me in the comments what all topics should I cover next. Till then, see you in the next video.